R.3, finding domain and range. So R.3, domain and range. This is a very important topic because every time we're asked to graph, every time we look at a pattern or a function, we need to determine the domain. After we graph, we can also identify the range. Sometimes we don't need to graph to identify the range, but sometimes we do. Okay, so I'm going to look at a couple of problems, like for example 50 on page 32. We are given g of x, which is x minus 1 divided by x squared minus 36. Okay, first of all, I need to identify the type of function. What type of function is it? Okay, we are not sure about that. So let's start with a simpler example in a minute. Careful. So let's say we have this function x squared minus 3x plus 2. What type of function is this? Awesome. What is the domain of a quadratic function or any polynomial function? Exactly. So let's start with that. Note, all polynomial functions are defined, we say everywhere, or on negative infinity to infinity. All real numbers, in other words, all polynomial functions. What does that mean? It means that in x, or in this function, or I can replace x by any value that I want. There will never be a problem. Good. So now let's go back to this function. And now let's try and identify the type. Once I identify the type correctly, chances are big, large, if you want, that I will be able to find the domain correctly. It is an absolutely irrational function. Rational function. It's a ratio of two polynomials. I see a fraction line and I see x in the denominator. Every time I see a fraction line and x in the denominator, it's a rational function or a combination with a rational function, but definitely something is going on that resembles a rational function. Okay, now here I did not have any situation or any problem, ever, because I can plug in x anything I want. But here I may encounter a problem. What is the problem that I may run into?
You can't divide by 0.
Excellent. So note, again, division by 0 is undefined. Undefined. It's a fancy word that really says it does not exist. Undefined. So then what do I have to write and say it cannot be 0 in that case? X squared minus 36 cannot equal 0. This is my starting point. This is a what type of equation? So I know how many solutions I have to write. 3. The degree is 2. I cannot find 3. If the degree is 2, I have to find 2. Good. I have several ways here. Let's say we factor. Very good. So two options, x could never be 6 and x could never be negative 6 in this function. In other words, if I ask you to plug in 5, will you be able to give me a number? Correct. If I ask you to plug in 0, will you be able to give me a number? But if I ask you to plug in 6, what will you say?
Undefined.
I cannot give you a number, right? It's undefined. If I ask you to plug in negative 6, what will you say?
Undefined.
Right. You can't plug it in because the denominator will be 0. Now the problem is really asking us to find the domain. At this point in time, we found the numbers that x cannot be assigned to, or numbers that cannot be assigned to x. But I'm asked to find the domain. So how do I write the domain of this function?
Couldn't it be any number?
But, any number but?
Negative 6 and 6.
Perfect. How do I write that? Excellent.
Negative 50.
Comma.
Negative.
Very good. Union. Awesome. Comma. Excellent. Union. Excellent. This is the interval notation for the domain. In other words, you could say in plain English, everything but 6 and -6. But we prefer this notation. Very good. Any questions? Okay, let's look at this function. And I'm looking at problem 52, same page, on page 32. And I'm given the absolute value of x plus 7. Oops, sorry. I'm asked to find the domain of this function. Is there a potential risk?
No.
If there is no potential risk, then the domain is? Is there a potential risk here? No risk whatsoever. For any x, you will be able to add 7, and you will be able to find the distance from 0, or in other words, the absolute value. Absolutely. Any questions?
So are all absolute value ones going to be that domain?
Very good question. Excellent. Let me give you another function, which is a combination.
Because it can't be.
It cannot be.
You can't put a negative in there, right? Because of the absolute value part.
The absolute value will always give us a positive number. I can put in any number I want, except -7. So the domain of this function is -infinity to -7 union -7 to infinity. So to answer your question, if the absolute value is not in the denominator, then the domain will always be all real numbers. But if it happens to be in the denominator, which is a combination, this is not a pure log, it's not a pure exponential, it's a combo. It's a rational function combined with an absolute value function. So in this case, I still have to worry about the denominator. But if it's an absolute value function with no denominator, then also always all their numbers. Are we okay so far? Okay, I would like to, before we move on, I'd like to look at a couple of graphs to identify domain and range. And I'd like to look at this function right here. So we are given, this is the incidence of breast cancer. The following graph gives us without, so they are graphing. So this is a, what type of function is this?
Quadrant.
If the degree is 2, it's quadratic. If the degree is 4, which it is, it's just polynomial, right? So blah, 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 x to the 4th, x to the 3rd, x squared, x, right? So it's a polynomial function degree 4. Excellent. So they're graphing it for us. They're asking us to find the domain of this function. You may not see, but this is 20, this is 30. I'm thinking that this is 25, and this is a little bit more than 100. What will be the domain of this function? From 25 to 102. What will be the range of this function?
0.
0 to hopefully whatever. Yes. So here's another question. What 10-year age interval sees the greatest increase in the incidence of breast cancer? So I would not even look between 20 and 30 because the function is not defined to the left of 20, to the left of 25. So I'm going to look here. So this is the increase between 30 and 40. Between the age of 30 and 50, this is the increase. So let's write this down. If you'd like to write it down for me, and then I'll write it down for everyone. So let's say between, if this is 50, what would you estimate here? 20? So between 20 and 100. So the first one is an increase, 80. Okay. So let's say between 40 and 50. This is
100.
100. Okay, between 50 and 60. 100 and
120.
120. Between 60 and 70. So between 320 and 420. So which one was the highest?
50 to 60.
From 50 to 60. So between 50 and 60 it was 120. And that is the highest increase on a 10-year interval of age group, in other words. Okay, that was the fastest increase between 50 and 60, 120.
Was that a question that you were answering?
No, this right here. What 10-year age interval sees? So yes, this is problem 59 on page 33. So 59 on page 33. So in part A, you told me between 25 and 102. In part B, you said approximately between, you said 0 and 450. Maybe it's a little bit more. I'm going to write 450 for now. And then you said in part C, the highest incidence, the highest increase was between 50 and 60 years old for this age group. Okay. Are we okay with domain and range, or should we look at another problem? Should we look at another graph to find the domain? Are we okay with that? Okay. So in that case, I would like to look at some applications with the linear functions. Okay, so this is in R.4. And that's slope and linear functions. Slope and linear functions. And I would like to look at a few applications. One of them that is kind of typical is the straight line depreciation. I'd like to look at 72. So I think it's tie line. Electric uses the function. We're going to copy it in a minute. B of t equals negative 700t plus 3500. B of t, negative 700t plus 3500 to find the book value, B of t, in dollars of a photocopier years, t years after its purchase. So it's very clear here. Can you see? Everyone? Okay. And how do I keep this? It's going to fall off. Okay.
Do you have a binder clip?
I was just thinking about that. I normally do. Here it is. Excellent. Very good. So we're given the function. We're also given the graph. And here's the first question, which is actually on the back. What do the numbers negative 700 and 3500 represent? So what is negative 700? What does it represent? So this is a function which is mx plus b. This is a linear function. Y or f of x equals mx plus b. So we're asked to identify what negative 700 is. And furthermore, I will ask also what is the measurement unit.
Slope.
It is the slope, which means, and what is so it's negative 700. What is the measurement unit?
Dollars?
Careful. When you call me and ask me what is your speed, I will never say 60 miles. Because it's a rate of change. I will say 60 miles
Dollars a year?
per hour, right? So every rate of change, it's a ratio. it has two measurement units, one coming from the top and one coming from the bottom. So negative 700 is blah over blah. So what is it?
Year.
Book value in dollars per year. Per year. So it's negative $700 per year. What does that mean? It means that what I purchased today for $10,000 or whatever, it will decrease, in a minute we'll discuss that, it will decrease its value by 700 per year. Okay? So the slope of negative 700 means that every year the value decreases by $700. So the measurement unit, I'm going to write this down for you, negative $700 per year. Remember, any ratio has to have two measurement units over this. Okay, good. Now the second question is, we're asked what is 3,300?
The starting point.
Exactly, the initial value. Because when x is 0 or time is 0, this is the initial value, 3,500. So let's write this down for now. So we were looking at problem 72 on page 45. And this was b of t, negative 700t plus 3,500. We know that the slope, or the rate of change of value with respect to value with respect to, say it again. Awesome, thank you, Maddie. Respect to time equals negative $700 per year. So this is the meaning of the slope. And you'll see what else is going to have the same meaning soon. Okay, then we said y equals 3,500 is the initial value. Of the photocopier. Initial value. In other words, when t is 0. Okay, let's see what else they want. How long will it take the copier to depreciate completely? Let's look at the graph again. How many years will the copier need to have 0 value? 5 years. So that's clear. The value initially was 3,500. It decreases by $700 every year. In 5 years, it's nothing. Clear? Okay. So then I will write for part B. This was part A, and this is part B. I'm sorry, not X, but time. T equals 5 years. This B of T, B of 5 years, equals 0. $0. So when we evaluate B at 5, we get 0. Okay, say it again? Yes, please.
If you didn't have the graph to look at, how could you easily get to?
Excellent. Very good. Excellent question. Thank you very much. So, when will B of T be $0? When will the value be 0? Nothing. How do I do that? How do I address that? Please, Maddie?
Set the problem to 0.
Set the function equal to 0. So negative 700t plus 3,500 equals 0. Awesome. What type of equation is this?
Linear.
Perfect. I have to move 3,500. It becomes negative and divide by negative 700. So then t equals 3,500, both negative, divided by 700. So t equals 5 years. Excellent question. Thank you. Okay, so also they have what is the domain of this function b? Let's look at the function one more time. You could say, well, this function is linear. linear functions exist for any real number? Yes. However, B of t has a practical meaning now, and I have to be careful. I cannot talk about negative years.
3,500, comma 0.
So domain, just domain, not the range, just the domain.
0, comma 0.
Exactly. In this case, the domain of this function, that's part C, 0, comma 5 is the domain. Absolutely. Although we know that a linear function is defined everywhere, however, for this is very clear. I would like to also look at, yes, please.
Why do you use brackets on that?
Very good, because the points exist. If I have, very good question, awesome, awesome. So, if I have a function like this, then the domain will be 0, 5. But these points exist. So therefore the domain is the bracket. So when the points exist at the end points exist, I use a bracket. If the endpoints don't exist, I use parentheses.
Would we be able to determine that without using a graph?
Um,
We have to.
For a linear function like this, it would be clear you don't have to look at the graph. Very good question, and I want to take a problem like that. So I'm going back for a moment to R.3. Excellent question. Okay, here it is. I'm looking to see if I can find the graph in here. Yes. Let's see. Let's take a look at this function. What is the domain of this function? -4 to 4, do you all agree? Because at this point, the function is defined and this one is not. But it has to have only one full point. At 0, the function is defined here. At 3. At 2, the function is defined here. At 2, and not defined here. So the domain is from -4 to 4. If any of these two endpoints were an open point, I would have used the parenthesis. So now I have a question here. Can anyone identify the range of this?
1 to 4.
With a comma, not with a parenthesis or a bracket. So the function exists only at 1, only at 2, only at 3, and only at 4. So I will have 1, 2, 3, 4. Not a bracket and not a parenthesis. Is that clear? Okay. So yes, sometimes I need the graph, and other times I really can find the domain and range without looking at the graph. Very good question. Okay, I still would like to look at a profit and loss analysis, like problem 66. Very good questions. 66, yes?
What page number is 66 on?
Oh, I was just looking at 45, page 45. Okay, profit and loss analysis. There is a computer firm and they're selling a new graphing calculator. That's interesting. For the first year, the fixed costs for setting up the new production. Fixed costs, they say, are 100,000. The variable cost for each calculator, variable. So this one is per calculator, $20. Oops. For each calculator. What else? The sales department projects that 150,000 calculators will be sold during the first year at the price of So revenue, $45 per calculator. And they predicted 150 will be 1,000. So they said 150,000 first year sales. Okay, I read and I take notes on everything. Find and graph C of X, the total cost of producing X calculators. So part A, the cost. So how do I determine the total cost? The total cost has two components. One that is so-called fixed and the other one that is so-called variable. So it's fixed plus variable. The fixed fixed costs do not depend on the number of units we manufacture, so that's 100,000. Plus, since for each calculator we pay $20, how much will we pay for X?
300,000.
It only says, let me see, you may be right, but it says, it does not say, it only says the total cost. It doesn't say how much it cost us to produce and sell 150,000. It only says find the total cost function. So at this point I would not include this because it says find the function for X number of units. Very good. So this is the function, and we want to graph it. Can anyone give us the X-Intercept? When X is 0, when we don't manufacture anything.
100,000.
Yes. So I'm going to say that this is 50,000, this is 100,000. So that's the first point. And let's say we want to manufacture 100,000. So then this is 50 and this is 100,000. 100,000 times 20, or let me just say just 10,000 for now, because I can easily get that Y value. Okay, so for 10,000 times 20 is 200 plus another 100,000 is 300,000. So that's easier for me to put in here. So this is 200 and this is 300. So this is the other point. So this is the cost function. When we manufacture 0 is 100,000 we have to pay for the fixed cost. When we manufacture 10,000, the total cost will be 300,000. I picked 10,000 for simplicity. You can pick anything you want, really. It's not important. Part B. Using the same axis as in Part A, find and graph R of X, the total revenue for the sale of X calculators. So in Part B, R of X. Can anyone give us the formula for R of X, knowing that the revenue for each is 45, and now we want to manufacture and sell X? What will that be? Yes?
45x minus 20x minus 5.
The revenue, we haven't gotten to the profit yet. So the revenue is just this, 45 times X. 45 times X. They're asking us to graph 45x on the same coordinate system. So can anyone give us the first point when X is 0? Very good, awesome. So let me use blue. Okay, so now let's make up another point. So for 10,000, and I'm getting in trouble already because I don't have enough room. So I will have to graph it again. My apologies. I did not plan ahead. That's what happens when you don't plan ahead. Learn from my mistakes. Okay, so I have to plot again. So 100,000, 200,000, 300,000. So now when we manufacture 10,000, this will be what? 450,000? Okay, so I have to go to 450,000. So this will be 400,000, and this will be 500,000. Okay. So now I think I have enough. I'm going to copy the first graph first. And we said that this was, I'm going to say this is 5,000 and this is 10,000 units. Okay, so at 10,000, this was at 300. And it started at 100,000. So this is the cost. And now in the same coordinate system, I will graph the revenue. 0, 0. And this is 450. So this is 400, this is 400, and this is 400. What is it? What is this? This is 450. So it's a little bit lower. Okay, so somewhere here. Good. So this is the revenue. I missed it a little bit, sorry. So R of X. Okay. So that was part B. They said using the same coordinate system, find and graph R of X and the total revenue. Okay. Part C, using the same axis as in part A, find and graph the profit function, the total profit from the production and sale of X calculators. Okay, so that's part C. In part C, we want to calculate the profit. Profit function will be revenue minus total costs. Revenue minus total costs. So P of X, revenue is 45X minus, in parentheses, be very careful, 20X plus 100,000. Because we must subtract from the revenue the total cost, not just the fixed and not just the variable. Okay, so then I will have 25X minus 100,000. This is the profit function, 25X minus 100,000. Okay, so now they are asking us to graph this function on the same coordinate system. I hope I don't have to graph it again. Who knows? Let's see. So when X is 0, how much is Y?
100,000.
But negative. So I would not even think of that. But it will be somewhere here. I'm not going to graph anything below the x-axis. Although I could, but I'm not going to. Okay? Good. So then when we manufacture 10,000, it's still negative, isn't it? No, it's not. It's 250,000 minus 100,000, so it's 50,000. Awesome. So here, this was 100,000, this was 50,000. Am I correct?
It's 150.
So 150. Oh, yes, yes. Thank you, thank you. So this is 100, this is 150,000. Very good. Awesome. Good. So here it is. My graphs cannot be perfect, of course. I don't expect that. And I would like to put all these three functions in the graphing calculator. In a minute, I would like to do that. Okay, so this is what I have as the graphs. Okay, what profit or loss will the firm realize if the expected sale of 150 calculators will occur? So do they make a profit? So their forecast was that they're going to manufacture 150,000 and sell them. Let's see if that happens. If they manufacture 150,000 and manage to sell them, because if they put them on the shelf and they keep them as the inventory, that's not profit, right? That's not revenue. It doesn't make profit. So let's see if part D, the profit of 150,000, if this is a loss or a gain. So let's plug it in and tell me what you get. So 25 multiplied by 150,000, and then minus 100,000. I got 3,650,000.
Yep.
Profit. That's good. Okay, there is also a part D. How many calculators must the firm sell in order to break even? So what is the break even? What is the break even point? We have to determine the break even point. What does that mean? When the cost and the revenue are the same, or when the if the revenue and the costs are the same, then the profit, exactly. So when the break-even happens, or the break-even happens when the revenue and the costs are the same, we're not making money, but still it's good because we're not losing money, so somewhat good. Or you can say the break-even point is when the revenue is 0. Okay, so let's set the revenue equal to 0. We already know what that is, pretty much where it is. Minus 100,000 equals 0. So then how much is x? Is 100,000 divided by 25, because this is a linear function. So 100 divided by 25 is 4, and I have 3 zeros. So x equals units. So if the company manufactures 4,000 and sells 4,000, they are only covering their costs. They have no profit whatsoever. So what is the break-even point? Obviously 400,000, and the break-even point does not have the y-coordinate as the profit, but the revenue. So the break-even point says x, comma, revenue of x. So we have 400, and I multiply it by 45. 4,000, I meant to say. Multiply by 45. So this is 180,000. So this is the break-even point. In other words, x, comma, revenue of that x.
What's the 180,000?
I'm sorry?
What is the 180,000?
Plug in the revenue. We plug in 4,000 in the revenue.
Going up, we should run into the revenue line over.
Yes. So that's why my slopes are not perfect. The measurement, the units are not perfect. That's why I said, let's do this. Yes, please.
Where did you get the 25 from again?
45 minus 20 is 25.
Oh.
And then I distribute it to 100,000. Is that okay, everyone? Sorry about not saying that.